Let's see today planar graphs. Phases of planar graph, boundary, degree of the phase of planar graphs. So a graph is said to be planar if it can be drawn on the plane without intersecting edges. A graph which is not planar is obviously a non-planar graphs. Let's see an example of planar graphs. You can see this graph which consists of 5 vertices. See, this edge is intersecting with this edge. Similarly, this edge is intersecting with this edge. So you can think so this is not planar graph, but definitely not. It is a planar graph since you can see this black line which I marked. You can just pull outside and connected with these two vertices. Just pull outside. You can see here in this graph. Similarly, the red line you can pull outside and join these two vertices. Now see, no edges are intersecting like this. So that we can say that this graph is said to be planar. But it is difficult to pull it outside and finding the definite planar graph. Oh, it's very difficult. But a little trick is there that you can see in the upcoming slides. Next you can see what is phases. G is a planar graph. Any plane that divides into the region is called phases. Any planar graph in which any plane divides the plane into the regions is called the phases. So in every planar graph you can see exactly one unbounded phases, and that phase is said to be exterior phase, otherwise infinite phase. You can see this by an example. Say this is a plane and you can see that any plane divides the region. This is a plane, triangle is a plane, and again you can see here this is a square, it is also a plane. Again another one plane is here, and this is the unbounded, that is a very exterior one. So you can see that this is a region, so that you can take that phase is F1 because dividing the plane. Now you can see this is a square, so that is also a phase F3. Again this is a plane, so the phase F2, and the very unbounded one which is noted as F4. So this graph will have 4 phases, F1, F2, F3, and the unbounded one is F4. So for every planar graph exactly one unbounded phase is there. Of course, finding the space in the graph into regions, dividing everything is very tired one. Very easy trick is there. You can see in the next slide. See how to find the tricks in the tricks of phases in the planar graph. Just remember this: modulus of V minus modulus of E plus modulus of F is equal to T. So V is nothing but the number of vertices, E nothing but the number of edges, and F represents the number of phases. Is equal to 2, then it is easy to find the phases. Let's see in this graph, it is in writing this F1, F2, F3, F, etc., etc. Just substitute here itself. See here, the P value, that is the number of vertices here is 8. So substitute here minus the total number of edges in this graph is 12. Okay, and phase is question mark. Okay, so modulus of F is equal to 2. Right, modulus of F, by solving you will get 6. So it is very easy to find the phases in the planar graph. We'll just substitute here modulus V minus modulus E plus modulus F is equal to 2. Right? And one thing you have to remember that this should be the planar graph. If it is a planar graph, only this will be satisfied. And how we can find this is planar? That you can see the next. See, I already told that this is a planar graph and pulling outside and finding is difficult. So how we can use a trick to find this graph is a planar graph? First, you should remember that that graph should be with cycle. Okay, without cycle, another conditions is there. This graph should be with cycle. If it's so, then these 3 conditions check. P greater than or equal to 3, Q less than or equal to 3R by 2, Q less than or equal to 3P minus 6. So P is nothing but the number of vertices, Q number of edges, R number of phases. You know that how to find the number of phases. P minus Q plus R is equal to 2, or modulus of V minus modulus of E plus modulus of F is equal to 2. Okay, you can see the first condition, P greater than or equal to 3. What is the value of P here? The number of vertices is 5. So 5 greater than or equal to 3, it is satisfied. So the first condition is okay, right? Now you can see the second condition. Q greater than or equal to 3R by 2. R is nothing but the number of faces. Just substitute here the number of vertices 5, number of edges in this graph is 9 plus R is equal to 2. From this you can find the faces is R equal to 6. Okay, just substitute here. Q value is 9, that is number of edges greater than or equal to 3 into face value is 6 divided by 2, cancel. What you are getting? Yes, 9 to 6, right? So 9 greater than or equal to 6. Definitely this also be satisfied. So the second condition is okay. Now you can see the third condition, Q less than or equal to 3P minus 6. The value of Q is 9, that is number of edges, less than or equal to 3 into number of vertices 5 minus 6. So 15 minus 6, that is 9. Of course, this also be satisfied. Therefore, we can say that this graph is a planar graph. Right? So remember, this trick will be applied only for the graph with a cycle, graph which contains cycle. Then see this three condition, you can say that without pulling outside any edges, etc. Just we can say that this graph is a planar graph. Remember to finding the phases condition, P minus Q plus R is equal to 2. Okay, if so, a graph without without cycles, then how we can say that that's a planar graph or not? You can see the next one. Okay, fine. Right. We can see a planar graph without triangles. Is it possible? See, this is a K33. Okay, complete bipartite graph. K3, 3, which contains definitely no triangles out there. You can check. So K3, 3 contains no triangles. If it's so, you have to apply this condition, Q less than or equal to 2P minus 4. If it contains triangles or cycles, anything, then you have to go to the last slide and prove the three conditions. It will be okay. But if it contains no triangles, just use this method, Q less than or equal to 2P minus 4. Q represents number of edges, P represents number of vertices. So here Q is equal to 9, that is number of edges, P is equal to 6. So just applied in this condition, Q less than or equal to 2P minus 4, substitute the value, you will get 9 less than or equal to 8. It is impossible. So we can say that K3, 3 is not a planar graph. If it's satisfied, we can say that it is a planar graph, but this is impossible, so it is not planar graph. So K3, 3 is not planar. Right. You can see the next one. Face. Each face is bounded by closed walk. Then we can say that is called the boundary of the face. Each face, you know how to find the face. It is very easy to find. Okay, each face is bounded by the closed walk. That face, that condition is said to be the boundary of the face. And the last figure we see, this is F1, F2, F3 and the unbounded one, F4. How we can find the boundary of the face? Just here, B of F1, boundary of F1 is nothing but IJ, JH, HI. Okay, closed walk. Closed walk. So IJ, JH, HI. So we can say that this is a boundary of face F1. Now boundary of face F2 is CD. This is actually here D. So CD, DE, EF, EFC. So that is the boundary of F2. We can see F3, BC, CF, FG, GH, HJ, JI, IH, HJ, again GB. So that is F3. F3 is covering this also. So remember that. And now F4. F4 is the outer face. So the closed face, you can take that as EAB, BC, CD, DE, EF, EFG, GB. Okay, so this is said to be the boundary of face F4. And if it is a closed walk, then you start with this BC, right? That here I'm just written the open walk. Just start with BC, CD, DE. The initial and the final vertices will be equal. Then we can say that as a closed walk. So the boundary of F4 is BC, CD, DE, EF, FG, and GB is called the boundary of F4. Now you can see how to find the degree of the face. It's nothing but the length of its boundary. The last slide we found out how to find the boundary of the face. Just by this itself we can find the degree of the face. So D of F1 is 1, 2, 3, right? And degree of face F2, the length of the boundary, 1, 2, 3, 4, right? And here you can see that the length of the boundary is, sorry, degree of the face 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, you can find for face F4. I hope it will be easy to find the phases, then boundary, length, everything. Yeah. Thank you.